Now we'll look at an example of determining the arc length of a space curve given by a vectored valued function. We're asked to find the length of the helix given by r of t for t on the closed interval from -5 to 8. Let's first look at this graphically. If we were to graph the vectored valued function, we would have this space curve or this helix. And let's go ahead and pause this. Let's let it rotate a little bit more. Let's go ahead and pause it here. Notice how there are 2 points shown on the helix. This is the point when t equals -5, and this is the point when t equals +8. The arc length would be the distance traveled from this point to this point if we travel along the helix shown here. So the distance this point is traveling to the point on the right would be the arc length, or the length of the helix. Another way to think of this is, if this was a coil or a spring, if we were to cut the spring at this point and this point, and then make it straight, the length would be the arc length. The arc length is equal to the definite integral of the magnitude of r prime of t integrated from a to b, which is equal to the integral of the square root of x prime of t squared plus y prime of t squared plus c prime of t squared integrated from a to b, or in our case, from -5 to 8. So to begin, notice x of t is equal to 5 cosine 4t. Y of t is equal to 5 sine 4t. And z of t equals 5t. Next, we'll find the derivatives, and then we'll set up the integral to find the arc length. So x prime of t is equal to 5 times u derivative of cosine 4t. Notice we'll have to apply the chain rule here. So we'll have 5 times the derivative of cosine 4t would be negative sine 4t times u derivative of 4t, which is 4. So we have a derivative of negative 20 sine 4t. And then for y prime of t, we'd have 5 times the derivative of sine 4t, which is cosine 4t, times the derivative of 4t, which is 4. So we have a derivative of 20 cosine 4t. And then for z prime of t, we'd have 5 times the derivative of t, which is just 1. 5 times 1 equals 5. Which means the arc length s is equal to the integral of the square root of x prime of t squared, which would be negative 20 sine 4t squared, plus y prime of t squared, which would be 20 cosine 4t squared, plus z prime of t squared, which would be 5 squared. We want to integrate on the interval from -5 to 8. Let's continue on the next slide. We'll begin by simplifying this radicand. So if we square negative 20 sine 4t, since negative 20 squared would be 400, we'd have 400, and then sine 4t squared would be sine squared 4t, plus if we squared 20 cosine 4t, we'd have 400 cosine squared 4t. Then, of course, 5 squared is 25. Now let's focus on these two terms here. Notice these two terms share a common factor of 400. If we factored out 400 from just these first two terms, we'd have 400 times the quantity sine squared 4t plus cosine squared 4t. And we should recognize the Pythagorean identity. Cosine squared 4t plus sine squared 4t is equal to 1. So this simplifies to 400 times 1, or 400. So notice how we'd have the square root of the quantity 400 plus 25. So we'd have the square root of 425. So this simplifies nicely to the integral of the square root of 425 integrated with respect to t from -5 to 8. Let's go ahead and simplify the square root of 425. Since 425 is equal to 5 times 85, and 85 is equal to 5 times 17, the square root of 425 is equal to the square root of 5 times 5 times 17, which simplifies to 5 square root 17. So we can write this as 5 square root 17 times the integral of, if we want, 1 dt. So we would have 5 square roots of 17 times the antiderivative of 1 with respect to t, that would be t. And again, our limits of integration are from -5 to 8. So we'll have 5 times square root 17 times, when t is 8, we just have 8, minus, when t is -5, we have -5. So this simplifies to 5 square root 17 times 13. So the exact arc length, or length of the helix, would be, well, 5 times 13 is 65, so 65 times the square root of 17 units. Let's also get a decimal approximation, which I've already done to save some time. It's approximately 268.0019 units. So if we go back to our graph one more time, the distance along the helix from this point to this point is approximately 268 units, meaning if this point travels along the helix from this point to the point on the right, as we see here, the distance traveled would be approximately 268 units. I hope you found this helpful.